Juno made it into orbit around Jupiter. But why should you care? Well, I'm going to tell you today on Vintage Space. Like pretty much anything happening in space right now, it really only makes sense in context, and Juno is absolutely no exception. So to understand why we should care about Juno, we've got to do a little bit of a history of Jupiter exploration and understand where this mission fits into the scope of our understanding of the gas giant. To start off with some basics, Jupiter is absolutely massive. It is so big you can see it unaided with the naked eye at night. Because it's been an easy object to spot, astronomers have been studying Jupiter for centuries. Ground-based observations got better as the years, decades, and centuries wore on, but it wasn't really until the advent of the space age that we were able to study Jupiter up close and properly. But even then, Jupiter wasn't an early target. While manned spaceflight was focused solely on landing a man on the moon in the 1960s, the planetary targets were largely Venus and Mars because they're our neighbors and they're easiest to get to. It wasn't until the 1970s that scientists started looking at the gas giants at Jupiter and Saturn. The first missions to ever visit Jupiter were the Pioneer probes, Pioneers 10 and 11. Pioneer 10 flew past Jupiter in December of 1973, and Pioneer 11 followed a year later. From these missions, we learned about Jupiter's magnetic field, its tilt, found that a strong ring current distorts its magnetosphere, found that radiation in the Jupiter environment is far greater than the same environment around the Earth, and found that Jupiter emits more heat than it receives from the Sun. Scientists also learned from these probes about the varying depths of the clouds that reach Jupiter's surface. These spacecraft also revealed a fine ring of particles around the giant planet. But neither Pioneers were able to stay. These were both flyby missions, and even before they reached Jupiter, NASA was working on the next round of Jupiter flybys with the twin Voyager probes. Both launched in 1977, Voyager 1 reached Jupiter in March of 1979, and Voyager 2 flew past in July of the same year. These twin probes discovered new moons around Jupiter and also confirmed the existence of a ring around the giant planet. Voyager 1 was also the spacecraft that famously turned around to take a parting shot of Jupiter and witnessed 2 erupting volcanoes on its moon Io. But the problem with the Voyagers was the same as the problem with the Pioneers. These were 4 flyby missions. None of them stopped and went into orbit and really studied Jupiter alone intensely. That came later with the Galileo mission in the 1990s. Galileo launched in the payload bay of the Space Shuttle Atlantis on October 18, 1989, and was then released on its winding path to Jupiter. Its mission, using an orbiter spacecraft as well as a probe, was designed to determine the chemical composition and structure of Jupiter's atmosphere and cloud layers, examine the planet's heat balance, study the lightning, and measure the energetic particles along the top of its atmosphere. The Galileo orbiter was also designed specifically to look and study Jupiter's moons. It was designed to look at the surface morphology and composition, as well as the magnetic and gravitational fields in which this whole system works. The Galileo mission returned some incredible science until operation ceased in February of 2003. It briefly turned on to transmit some last data as it plunged into Jupiter's clouds in September of that year. But ultimately, Galileo told us that we really didn't know nearly as much about Jupiter as we thought. Data from Galileo told us that the composition of Jupiter was actually different than we originally thought going into that mission, which in turn meant that we didn't know a lot about how the planet formed, and by extension, didn't know a lot about how our own solar system was made. So there was obviously a need for a more intense study of Jupiter. The problem was, after Galileo, we went back to flyby missions. The Cassini spacecraft, currently orbiting Saturn, the Ulysses spacecraft, which is a solar mission, and the New Horizons spacecraft, which passed Pluto last summer, all briefly visited Jupiter on their way to their final targets or their final orbits. So Juno may be the 9th spacecraft to fly past Jupiter, but it is only the 2nd ever mission dedicated to studying the gas giant. So what is Juno going to do? It's going to unlock Jupiter's secrets and tell us how our solar system was made. Leading theories of planetary formation say that gas giants like Jupiter are the cornerstones of planetary formation. These planets form early in the process of a solar system forming around a sun and have an immense impact on how that solar system forms. Not only do they suck gas out of the spinning disk of gas and dust when that solar system is young, they have such phenomenal masses that they impact the way the other planets are formed and settle into their orbits. If we can understand what Jupiter is made of, what its composition is, and how and when exactly it formed, we can understand how our own solar system was made. So not only will we learn a lot about where we came from, we can apply that to other solar systems. Jupiter-like planets are some of the most commonly found planets when we're looking for exoplanets, that is, planets orbiting other stars, simply because they are so huge they're easier to spot than something the size of Earth. If we can understand how Jupiter formed and how its formation impacted our own solar system, we can apply that to other solar systems, other systems around distant stars, and maybe use that to help us narrow down the search for planets that could harbor life. So it must be said that that is the absolute Coles Notes version of the history of our Jupiter exploration and why Juno matters. If you guys have more questions about specific past missions, or even if you would like to see full videos done on these missions unpacking more of the science goals, let me know in the comments below, because really each of those missions deserves a video on its own, specifically relating to Jupiter. Did you guys realize that Juno is our second ever dedicated mission to Jupiter? Do you feel a little bit differently about it now? Are you more excited for what it's going to find? If you guys have more questions about Jupiter exploration or Juno, leave me those questions and comment in the comment section below, as well as anything related to Jupiter or any other space things that you would like to see covered in future episodes. Be sure to follow me on Twitter for daily Vintage Space content as AST Vintage Space, and I'm also on Instagram, which I will say is more of my normal life. And of course, with new videos going up every single Friday, subscribe right here so you never miss an episode.